.edu. Okay. So probably the biggest question, and maybe why we don't have a lot of members in RF Club, is that not a lot of people realize that it's actually cool to care about RF. Obviously, radio means no wires. That makes it really useful for things like emergency situations or anything else when you're short on material, short on power. Radios can usually get the job done. And something that's probably very helpful for you electronics people is it's very easy to modify and mess with radio things on both the software and the hardware side. Larry?
I did this slide, so I can do this one.
Okay.
If you want. What's our plan? It's kind of late for this. Amateur radio. Amateur radio is ham radio, which is a hobby and enthusiast interest in radio communications technology. To further develop craft and skill of radio operations. Deep was pointing to Larry, so I'm sure he can kind of elaborate on these things that I wrote out in the slide. You can get a license. You have to get licensed to be able to broadcast or to communicate through the frequencies for amateur radio. So you can get your technician license or your general, or the highest license you can get is the amateur extra license. They are, and you just take an exam for that, which I think every year W8LT, we kind of help people get licensed. I know I did that last year. And we've got plenty of different types of radio and communication kind of methods. There's software-defined radio. You can get a mobile radio, QRP, which is low-power radio broadcast, D-Star, which is digital, Morse code, slow scan TV and amateur TV, and a whole bunch of other kind of methods and mediums for radio broadcasts or radio communication. And it's fun. Radio communication science, fun. You can contact people from all over the world, or even in orbit, as the last slide mentioned. You can talk to people in the International Space Station. You can also volunteer with ARIS, Amateur Radio Emergency Services, to help with communications during weather disasters. And you can also just develop your tech skills with fun build projects, making antennas, or even making your own radio receiver and those kinds of little things that you can do. So.
Yeah. And probably the only thing you really need to know to start doing stuff with radio is just about this much, which is how I came into it. We have the handy dandy numbers and symbols formula for waves, which I have handily translated to words that make sense to me. Basically, you do categorize waves into more than just two categories, but you have higher frequency and lower frequency, high frequency, small waves, small antennas, small range. So you think Wi-Fi, and then you have low frequency, big waves, big antenna, big range. And that would be stuff like the radio that you listen to, or 8-meter radio to communicate with far away places. I expect that most of what you will all be making will be more on the high frequency side, so smaller antennas, but do not be scared of the large antennas. They can always be fun, especially with the range that they provide. And this is mildly overwhelming. You could see how the FCC has mapped out different frequencies for different things. The idea is that the same frequency won't have like multiple functions, because otherwise you just hear complete noise. You kind of break it down further in the band plan, which are the ones that we as amateur radio operators would use, as this covers things that are like the corporate side, or things that nobody is allowed to mess with unless they pay the FCC a lot of money.
All right, I'm unmuted, right?
Yes.
Yeah, cool. So the band plan explains the different frequencies, as Deep was mentioning, of what you get to use when you're licensed. So this can vary all the way from down to 135 kilohertz all the way up into the gigahertz range. The different levels of testing, so you start off with the technician, then general, and then amateur extra, gives you access to different frequency allocations. So if you take the first test, you typically get access to what's known as a 70 centimeters / 420 megahertz, and you also get access to 2 meters / 144 megahertz. Small segue, the rough approximation, if you to the previous slide about calculating frequencies and megahertz, is you take 300 and divide by either the length in meters or the number in megahertz, and you'll get the other one. So approximately 300 divided by 30 meters gets you about 10 megahertz and vice versa. So it's a quick, if you like mental math, it's a great way to flip between the two. And as the different modes were mentioned as well, so for example, in this chart, green would be phone and image, and red would be data transmission. So like data would be, example, your amateur television, FT8, and different modes like that where you're typically using a computer or some other digital medium to send it. And as you take more tests, you get access to more lower frequencies, and you get to do more fun things. So, and you get to travel further down in the frequency range. So if you don't have a license, what can you do? So there's citizen band, which is also known as CB. There's multi-use radio, or MURS, and there's also FRS, which is family radio service. All of these allow you to use a radio without having to have a license. And they're different frequencies. So citizens band is near the 10 megahertz, or not 10 megahertz, 10 meters ham band. It's approximately 11 meters, and it's about 27 megahertz. It's channelized, which means that if you have a CB radio, you can change between 1 to 2 to 3 to 4, all the way up to 40. Some people jokingly call us the trucker radio or the trucker band, because channel 19 typically is used for people who use long haul semi trucks. Multi-use radio is on 2 meters, or about 151 megahertz. It has a little bit longer of a range, but you're limited to 2 watts instead of 4 watts, and you only get 5 channels. And then family radio service is in the 462 to 467 megahertz range, and there's 14 channels instead of 5. You're still limited to 2 watts. So the range on all of these in terms of actual distance is probably a couple of miles in best conditions. I think I've seen the like 3 miles, maybe 5 miles would be pushing it, but probably 3 miles or less, as long as you're using a radio that's within the wattage limit.
Probably also the most relevant part for Make, and also for the things that I do, because I don't understand hardware that much, is SDR with the cute little heart that I didn't see before. It symbolizes all the love that we have for SDR, which stands for Software Defined Radio. It lets us do wacky things with radio rather than just listen and transmit. You can send images, you can receive images, and you could do that on your Windows PC. But SDRs are also really important because you can use them on your Raspberry Pi, so you can write whatever you want loaded on and then be able to run it without using a screen. Just you and your tiny microcomputer connected to an antenna. And another big part of SDR is there's intranet SDR, and those links, QESDR and WebSDR, means that you can control radios that are at your current physical location, so you can listen to stuff.
Yeah, so, well, they're connected to, they're from you can listen to them from your location, but you're connecting to a receiver from a totally different area. So you can connect to a software-defined radio in like Russia and listen to the signals that you would be able to hear from that location, but you're on the completely other side of the world. So there's a lot of exciting. It's an exciting kind of medium for a lot of like receiving a lot of different frequencies. I don't know a lot about transmitting with SDR though. There's my idea.
Yeah. No, I appreciate. Yeah, I didn't realize there's probably a large network of people that are just very kind, connecting their SDRs to the internet so that anyone can tune in. And we kind of did cover that a little bit. SDR has a lot more flexibility than analog radio. Probably the best thing and the coolest thing is that you can have the waterfall, which lets you look/listen to a ton of different signals at once. So if you're not sure what frequency you're trying to listen to, you can see what's going on at frequencies near it. It helps with finding things that you're not quite sure you're looking for, and also just monitoring a ton of other stuff. And it helps eliminate noise digitally. So if you're really far away from your thing, or you're not sure if you're hearing the right thing, SDR can help you narrow that down. Transmitting is not exactly the same, which is, I guess, a downside.
Well, no, it's not that it's not a downside, but the software-defined part of it's the same whether you're receiving or transmitting, whether you're modulating or demodulating. That's all in software. The difference is the amount of power you have to put out. If you're transmitting, you have to send a lot of power to the antenna to send the radio signals out. So software-defined transmitter isn't something you're going to buy on the internet for $10. You're going to spend some heavy-duty cash to have a 100-watt or a 500-watt or 1,500-watt SDR transmitter, right? The principles are the same, but receivers are small and cheap and lightweight. Transmitters, because they require a lot of power, are a lot more expensive, right? High-powered silicon, I guess. High-powered hardware is expensive.
Yeah, and that's why we keep it all in Beavis in the basement. Our ham shack where, yes.
Well, you're right. There are hams who actually connect their station to the internet and allow people to log on and operate both transmit and receive.
Yeah. It's very cool.
It's called remote hams.
Yeah.
I think it's remotehams.com or remotehams.net. They make you prove that you have a license because it's illegal to transmit without a license.
Yeah, I think aren't there like a couple new apps and other kind of development? Is that what I know we were talking about maybe using one of those kinds of transceiving apps for W8LT before.
Well, we talked about trying to make the W8LT station accessible over the internet, and our problem is the university's OCIO does not allow us to have the kind of access to the network that we need to be able to get the signals in and out.
Yeah, it's a lot of firewalls and things like that for internet.
Poke holes in the firewall, and they frown on that.
Right for them. Speaking of frowning on pirate radio, there are radio enthusiasts who are bound to break the rules throughout history. That's a thing that has been a problem. Some people build their own transmitters to illegally send media and communications over frequencies allocated for both radio operation and official radio stations. So they'll just go anywhere along the bands for some fun. So pirate radio has been a pretty consistent problem for the Federal Communications Commission. Yeah, that's right. And the international counterparts since radio's creation, basically. But it's become a bigger problem with advancements in transmitter size and mobility. Now that transmitters can be smaller and be moved easier, people can kind of avoid getting detected for longer. And although it's called pirate radio, there are actually, throughout history, there have been prominent pirate radio stations that did broadcast from boats and overseas. So they're pirate radio, which allowed them to stay mobile and easily avoid the law. Up in the right corner, there's REM Island, which I think was off the coast of Ireland, they built a little broadcast station out on like a bay. This is from quick Google searching. You can know more than me faster than this, but so they were broadcasting 24 hours, 24/7 from that station, and they couldn't be touched essentially because they were far enough off the coast that there was some dispute over their both reaching them and like taking them to justice or whatever. And then Laser 558 was a European pirate radio station that was on a boat that would go around offshore in international waters to broadcast over to Europe. So there's a lot of kind of fun. Those are more of the bigger stations. There's a lot of way smaller ones that people just kind of hide on roofs and in garages and that kind of thing, just to make it easier to kind of reach people. So, but then the next question is, how do you catch a pirate radio, a radio pirate? So far from what I can understand, it's mostly just direction finding, where they use specific antennas on vehicles. The old picture on the right is from a direction finding vehicle from World War II in Europe. So after being alerted of an illegal signal, the FCC agents are then sent out in a vehicle with that direction finding technology, which is usually an antenna, radio receiver, and some kind of mapping device with a compass so that they can kind of move toward the signal via compass. And once those agents pick up that signal from their vehicle, they can circle the source area and they plot lines of bearing lines on their map to kind of triangulate where that transmitter is located. And once they find that specific area, it might be a building or a field or something, then they have to go on foot to like track down the exact spot that this transmitter might be. And then the transmitter might not even, like, usually pirates will have like their studios will not be connected to the transmitter. So once they find the transmitter, they have to find out who is who did it. So there's a whole lot of complicated kind of investigating that FCC agents have to do to really catch pirate radio. Sometimes it's easier, sometimes it's tougher, more difficult. And there's actually that link at the bottom is to an interview with one of those FCC agents who tracks down pirate radio stations, and he gives a lot of insight. They give a lot of insight onto how that works, since it's a really interesting and sometimes confusing kind of method of law, I guess. Yeah. So
yeah, then some popular radio modules that pair well with Arduinos We see two here. One of them's the ESP8266, which is this one in the top right. That's capable, it has Wi-Fi capabilities, and it also pairs well with an app called Blink. We did a workshop in the past where you could control your Arduino via this Blink app over Wi-Fi using this module, which is really neat. They also make a standalone version of this. So this version here, you could add that to your Arduino or any microcontroller, but Arduino seems to be the easiest. But they also make a microcontroller that has this ESP8266 built into it, and it has a bunch of GPIO pins and all that good stuff. At the bottom of that last page, we have the Nrf modules. This little guy down here. We also did a workshop on this in the past. Those were kind of hard to work with. If you see, it has 8 pins on it, and I think having all those wires go to the Arduino, maybe there's some interference. I don't know. We didn't have much reliability using these, but if you could figure it out, they are pretty cool. This is a transceiver module, so this could both transmit and receive, which is neat. And each module could talk to 125 other modules, which is also pretty cool. You could go to the next slide, who's ever controlling, thank you. And then these next two slides are what SDRs look like, 2 examples of SDRs. Again, with SDRs, you could listen to all sorts of radio communication, like CB, ham, police, and EMS. Last semester, we did a workshop using the SDRs where we were able to track, we could see air traffic in live time using the SDRs paired with some software. That was a lot of fun. These SDRs are like 20, 30 bucks. So it's a cheap way to get into the game.
I have that Nrf version. It was about $30, and it came in a kit, kind of like the RTL one here, with its own antenna. But yeah, it's definitely. I've also been able to kind of like track pagers going off in the nearby hospital and a lot of other interesting kind of digital signals, which are really fun to kind of see and classify with the SDR waterfall.
That's cool. I also heard with the SDRs you could capture signals, and then you could recreate those signals and basically treat the SDR as a remote control or anything of that sort. What we see here is another RF module. The smaller square one, that's the transmitter, and then the rectangular one is the receiver. So unlike the Nrf, both can't transmit and receive. One transmits, one receives. And you do have to add an antenna to this. Basically, you just take a wire and solder it onto the corner where it says antenna. And you do that for both these modules. And then to figure out your antenna length, you do, I think it's what the speed of light divided by your frequency, and then these, you could use a quarter wavelength antenna, so it ends up coming out to about 17 centimeters. And these are fun. Apparently with these, I was reading that you can't operate them all the time, and you can't put too much power through them without a ham radio license. I'm not exactly sure why. Maybe you guys have some insight on that.
I assume because you said, did you say that you can't have a lot of power through these without a license?
Yes, and a radio also have to operate them intermittently. You can't just constantly be.
I assume it's because you end up like interrupting the airwaves a little bit too much. If you're not doing it intermittently, and I think above kind of like that slide about how MERS and SR are like 2 watts to 4 watts. I'm assuming if you go over that and with anything else, that's against FCC regulation.
Okay.
As well.
Yeah, the FCC regulation, I think, is based on effective radiated power. So it's how much power is coming out of your antenna. So the bigger, fancier antenna you put on it, the more power you can send in a given direction. But then you start running in, if you just hang a chunk of wire off the end of this board, it's only going to have a range of a few hundred yards, maybe. If you hook it up to a well-designed multi-element directional antenna, you might get several miles out of it with the same power coming out of the chip. But the limits are how much antenna power, how much effective radiated power is what they talk about. How many watts are actually coming out the antenna, and they don't regulate these very low power things. They don't interfere with many other broadcasters, and they couldn't regulate them anyway because they couldn't find them most of the time.
Gotcha, that makes sense. Thank you. And I guess this 433 megahertz range, most of the equipment that operates in that frequency is things like garage door openers, headphones, baby monitors, remote controls, that kind of stuff.
Oh yeah, MISC projects. I know. Yeah, I know. You can actually like hear the television when you press a button on a TV remote. You can hear it with a shortwave radio or transistor radio. So yeah, no, there's a lot of interesting kind of things that you can do with those low-powered kind of transmitters. FM, some miscellaneous projects you can also do. You can build your own radio receiver. It's one of the most simple projects to do that you can start out with and become familiar with radio technology. You can make a shortwave receiver or FM, AM, that kind of thing. I know there are also kits you can get to make it easier. You can also build your own antenna. I know W8LT, we do that every year, except for this year because of COVID. And I haven't done it yet. I really want to. It means that you can make your own equipment for your Radio Shack. There's also aircraft tracking. I don't know much about that. If Deep has any information on that. No. You can track aircraft. Yes. Slow scan TV there's a lot of interesting kind of modulation or data transmission stuff you can do with radio. SSTV means that you can send and receive pictures over radio, so people will just send data with their call sign out to see if anybody will receive it and then maybe transmit something else about. And that's just kind of an interesting additional possibility of radio communication. And then something I don't know a whole lot about is Qrp operation, where it's a corner of the amateur radio hobby where people will build very low power transceivers, so they'll be less than 5 watts, and attempt to make long distance contacts. There are like conventions for QRP, and it does require a lot more skill and antenna building and operation, because you're trying to get signals that are going to be very unclear because of radio propagation and that kind of thing. But people will make these really tiny transceivers in like Altoid tins, as you can see in the bottom right corner, and then do Morse code with a little paperclip or something like that. And it's kind of a fun little addition to what you can do with radio.
Little, but yeah, you're right, is V small. Speaking of the antenna building workshop, it is actually coming back, but we're doing it safely and far away from each other, sadly. We're going to do it over the course of either 2 or 3 Tuesdays. Here are our Tuesdays, the 9th, the 16th, and the 23rd. And we're going to have it set up so that you can pick up materials. And when I say materials, as you can see, it is PVC pipe and measuring tape. So that combined with glue. So not too complicated. Obviously, we have our Discord, which is radio specific. Feel free to join that. If you end up doing anything radio related for Make, I'm sure that someone in there would be able to help you out or just get started with SDR, even if you're not doing a project with it. Just something for fun. There's the RTL SDR forums. They are super helpful. Everything SDR kind of links back there. And Signal Identification Wiki if you are like me and you get confused between what GHC, MHC are. And if anyone has any questions, now would be the time.
When you say